Okay, for rewriting, basically, here, I'm just going to show you the general idea with an example off to the side. If I have x to the 2/3, that would be the same as x squared to the cube root. So the number in the denominator becomes what we call the index of the root. So that just means what kind of root are you taking. And then you have the numerator becomes the exponent of what's inside the root. So if I was looking at 46, if you don't have a number as the index, well, it's a square root, which means you have a little invisible 2 there. This cubed is on all of the 7p, so I'm going to keep the parentheses 7p. Here's the numerator, and the index is the denominator. So I get 7p to 3/2. On something like 48, notice what is the invisible exponent on the 4? 1. So I have 2 separate things going on there. Well, I'm going to do it in the same method. I'll just have 2 separate fractions. So I'll start with the 4, numerator, denominator, 4 to the 1/3, and then I have x, numerator, denominator, x, 5/3. So if I want to go in the other direction, I just kind of start with the root because I know I'm going to have the root there. And then I just look and say, what is my exponent attached to? In this case, what is your exponent attached to? All of 10x. And so I'm going to keep the parentheses. What becomes the exponent on the inside? The 1, yeah. And then the 4 is the index. And then I can simplify the inside if possible. So 10x to the 1st. That's just going to be the 10x there. On 52, what is your exponent attached to? Just the x. The 6 has separated itself. It is not involved. And so the 6 is actually going to stay outside of the root. I know we're attached to the x. There's the numerator, so it comes inside, and then the denominator becomes the index. Most of the time, you're not going to see the invisible 2 there, so we can just rewrite it as the square root of x to the 5th.